Hello all, welcome to another great week on statistical analysis and talking about the various statistics. So here this week we are going to talk about the independent sample t-test, the Mann-Whitney test and the dependent sample t-test. They are nearly related to each other, and so all of this is going to be a lot of fun. So last week was when you guys discussed about one sample t-test. So basically in that case, it was that there was just one sample that was taken from a population. But this time we actually have two samples taken from the population which are independent of each other. So when you look at what analysis needs to be done, is the fact is we should have one independent, my independent variable should be a dichotomous predictor, a nominal data set that has a dichotomous value. Now, why does it have a dichotomous value? Because it has two groups. We only have two samples in our independent sample t-test. If we have more than two, then we do the ANOVA. So since we only have two samples, we are going to say that it is a dichotomous, so it can belong. The participants can be either in group 1 or they can be in group 2. And then our dependent variable is a continuous outcome. So in this case, what it is we are seeing whether the researcher sees that there is a difference in the anxiety scores of participants when they see a picture of a spider versus when they actually see a real spider. So what this is basically, you can think about this to be like your control group and experimental group. So you have an experiment or you did something and then you are measuring it, and the other group you don't do anything, no experiment or no intervention, and then you are measuring it. So the group that has shown the picture of the spider could be my control group, while the group that has actually shown the real spider, so that is what I am bringing in, the X is the intervention, and then I measure about that group. So this is like a control group and experimental groups type of situation. So first thing is we need to state our research question. That is the very first thing we do for everything. What is the difference in the mean anxiety score of participants who see a spider, picture of a spider, versus the mean anxiety score of participants who see a real spider? So this is what I need to find out. The difference between the mean anxiety scores of participants who have seen the picture versus who see the real. And the real is my experimental group and the picture is my control group. So now the second most important thing is we state our null hypothesis. Remember how the null hypothesis is stated as a no difference situation. So basically what we are going to state is there is no statistical difference in the mean anxiety score of participants who see the picture of the spider and the mean anxiety score of the participants who see a real spider. So there is no statistical difference between these two scores. So if we look in terms of symbols, mu, remember it is mu is the symbol for the population, and so we are making inference about the population from a sample. So this is the sample. So mu1 is the average anxiety score of the population who see the picture. So it is a sample from a huge big population and they have only been shown the picture. So mu1 is the anxiety scores, average anxiety score for the population that see the picture. Mu2 is the average anxiety score of the population that see the real spider. So how do we say our null hypothesis? H0, remember, colon, mu1 is equals to mu2, and mu1 and mu2 are italicized. So this is our null hypothesis. This is how you will state your null hypothesis in the words and then actually define your variables and write the statement. So what is my alternate hypothesis that I have to do? The alternate hypothesis is the opposite of what I have stated in the null hypothesis. So I say mu1 is not equals to mu2, which means the average anxiety score of the population represented by the participants who see the picture is not equals to the average anxiety score of the population who see the real spider. So basically I'm saying that there will be some statistical difference. Now, I do not define whether one score is more than the other score. So this is called a non-directional alternate hypothesis. If I want it to be directional, I can say that mu1 is less than mu2. That means the average anxiety scores of participants who see the picture is less than the average anxiety score of who see the real spider. Or vice versa, that who see the picture is more than the real spider. Even though I'm not sure why I would state it like this if my real spider group is the experimental group. But however, for the purposes of simplicity and purpose of just to be following, we will keep using our non-directional alternate hypothesis. So what we did was we had this design in which we stated our research question first, then we stated our null hypothesis, we stated our alternate hypothesis. Now we need to set the criteria for rejecting the null. To set the criteria for rejecting the null, remember how we use the common one. I will reject the null hypothesis if p-value for the test is equal to or less than 0.05, or if 95% confidence intervals do not include 0. So we will just basically go with this one. If p-value, this is my level of significance. So basically p-value is less than 0.05. So the first thing we have to do is to make sure that the assumptions for this test are met. So let's go back to our assumptions chart. This is 4 assumptions are there when we are doing this. First assumption is when the sampling distribution differences should be normal. So they should have normality. And there are 3 ways of finding out the normality. First way is the visual analysis. Second is whether your n is greater than equals to 30. And then the next is the KS test, which is the Kolmogorov-Simrov test. It is a mouth. So I will just call it the KS test. The second is whether the dependent is variable or the data is measured at least at the interval level. Variance in the populations are roughly equal, that is the homogeneity of variance. That means across the mean, the population variance are roughly the same on the left and the right side. And then the scores are independent, which means that the score of one participant is not dependent on the score of the other participant. This is very, very important because if you do not have assumptions met, then you actually end up doing the Mann-Whitney test, which is our second thing. So you have to have your assumption met and test for every assumption. So we will go back and look at the assumptions. So here are all the assumptions. So let's start one at a time. Okay, so for the normality, I have 3 ways of testing it. First, I test it visually. So I am going to make a histogram to find out whether it follows the normal distribution or not. So I'm going to open up my SPSS. Here I want to make sure you guys understand this. I put in the Excel sheets for the data. And I do not know if any one of you has SPSS or not. If you have, you are more than welcome to use the copy and paste the data set and run statistical analysis for yourself, but you do not have to do it. I would like to show you how the SPSS statistical analysis are run so that you have an anchor or a visual of how are these numbers coming about. Where do they come about from? So all of those things is necessary, I feel, just to get a background of it. So I will do it, but all the output statements that we have is there in the file. So you do not have to run any statistical analysis. I will give you all the output statements, all the histograms, all of that stuff. You are just interpreting the results, or you are just understanding how to write the results, or how to check for normality, homogeneity, and all that stuff. So let me open up my SPSS file. So here is the data set in SPSS. As you can see, we have the participant number, and so we had 24 participants, and we have 0 and 1. So those are the two groups I have, and then these are the anxiety scores. So this is something we really need to talk about, is the dichotomous variable, the nominal dichotomous variable for the group. So if I open this up over here, you can see that this is a nominal, and this is also a nominal data, though the group is my dichotomous one, and then this is my scale data. So what does 0 and 1 represent? So here is the Excel sheet. The 0 represents that the person or the participant in that group saw a picture of the spider, and 1 represents that the participant in the group saw the real spider. So this is one thing that we need to understand, is we have 24 different participants. So that is why it is an independent. So participant 1 just did one group. It only is in one group, and that group is 0. That means that participant saw a picture of the spider. And then participant, let's say, we go back to our data. This is not. If we go back to the data, participant 15 was in the group that saw the real spider, and this was the anxiety score. So the choice, the grouping, or 0 or 1 represents the group that they belong to. It is not saying anything else. It is just denoting the group, and that is what we want to understand, is it is 24 different participants. They've been assigned randomly to one of the groups to see a picture of the participant, picture of the spider or the real spider. And the real spider group is my group that I am doing the experimental group, and then this is my control group. So if I create my histogram, so I go to analyze, I go down to descriptive statistics, and I click on explore. In this explore, I put my anxiety score as the dependent score, and my factor list would be my group, because I have two factors, the group 0 and group 1. Group 0 is they saw a picture of the spider, and group 1 is when they saw the real spider. And then I'm going to make sure that I have a histogram, not a stem or leaf plot. And I press continue. Okay. So my output should open up, and this is what the output opens up. So the output that opens up, this is the histogram that opens up. So if you look at the histogram, it nearly does look like a normal distribution. So I could say the visual representation shows that it is satisfy the normality. Once again, all the diagrams, all the tables, all the figures that you need are in this document. You do not need to run SPSS. You do not need to put the Excel sheet. If you have and you would like to work with it, that is really awesome. So then this is my normality. It says, okay, the first one says, yes, it runs. Now let us look at, so this one was for the anxiety score for the picture group. But if I look the anxiety score for the second one, this one doesn't really look group 1. So this one is for group 0. This is for group 1 when they saw the real spider. This doesn't really look like a normal distribution. So I am still confused whether it follows the normality or not. So the visual representation. So the second way to do this is to run the KS test. Even before that, we can actually look at the number of participants. If my number of participants is more than 30, then it actually satisfies the normality. But number of participants is again not more than 30. So we need to go and actually do the KS test. The KS test is called the Kolmogorov-Smirnov test, and everybody calls it a KS test, but that is the full format. So how are we going to run the test? We are going to do the same thing, and I'm going to open up my data set, go to Analyze, Descriptive Statistics, Explore, and in this case, when I do the plots, I'm going to say I want the normality plots with the test. And so I'm going to do that. And so if you look at it, this is the score over here. So how does this test work? This test says that if your significance is greater than 0.05, this is not the level of significance. This is not the P selected for rejecting the null. This is for the KS test. So it says if the P is greater than 0.05, that means that it satisfies the normality condition. So in this case, for the picture, it is 0.2, and for the real spider, it is 0.2. In both cases, it is greater than 0.05, so it satisfies the normality condition. And here, see, there's a third way. I just put it as a third way, is to check whether the sample size is greater than 30 or not. I generally do this before I do the KS test, because in this case, it is not more than 30, but the KS test, which shows that it does satisfy the normality distribution. Now, the next thing is we want to see is, assumption is, does the dependent variable is a continuous? Is it a scale? Yes, it is a scale because it is the anxiety scores of all the participants, and they do have, it is in a scale. The type of measurement is a scale. So that is satisfied. Next, we want to see whether the homogeneity of variances are there. What does that mean? That means that the score spread over the mean is nearly the same on the left and the right side. So that is what we want to see. The spread of the score is the same. To check the spread of the scores, you do what is called the Levine test. How do we do the Levine test? We go back, we go to Analyze, Descriptive Statistics, Explore. This is our Explore. When we click on the plots, we actually click Untransformed. Okay, so when we do that, our plots open up, and here we again get the normality, but this is the homogeneity of variances. The Levine score is over here. Give you all of the information. So let's go back to this and look at it, that what does the interpretation of how do we know? Okay, so here is your table. It gives you based on mean, based on median, based on mean with adjustive, degrees of freedom, and then trim. And so here when we look over here, all of these significances are again greater than 0.05, and so that means the homogeneity of variances is satisfied. Okay, so look at this way. We have 4 assumptions. We have the normality assumption, which we saw that one of the histograms looked like a normal distribution, but the other really did not. When we checked using whether there were more than 30 participants, they were not, but the KS test showed that it was greater than 0.05 significance. So yes, it is normal. And then we had the interval measurement that is satisfied. The homogeneity of variances is satisfied because the Levine test shows that the significance is greater than 0.05. Remember, here we are talking about greater than 0.05. This is not the rejecting of the null. This is seeing whether these assumptions are met or not. So the last assumption that we see is the independence. Independence basically means that the score of one participant is not affecting the score of another participant. So we have no reason to believe that one participant's score influences another participant's score because I saw a picture of the spider, that's it. And you saw a picture of the you saw the real spider, but we are not like meeting, talking, or anything like that. So we can assume that. This is one of the assumptions that we take into account when we do the dependent sample t-test, because you have the same participants that is seeing the picture and the real spider. So we talk about the independence because we can even still talk about the fact that in that case also, does one participant score affect another participant score? So that is what it is. And even if you're talking about the same participant, the score of the picture and the spider is not affecting each other. And we'll talk about that in the dependent one. But for here, it is that in the independent sample t-test, one participant score does not influence another participant score. So we can say that assumptions, all the four assumptions are met. So now let us write a report about it. This is your script to write the report. There will be a Word document uploaded. So you can actually copy and paste the script. And so when you do your assignment, you change the numbers and change if there is something that is not satisfied or anything like that. But this is the script. Let me go through the script in detail. An inspection of the data indicated that all assumptions for an independent sample t-test have been met. So things to notice about the fact is it is an independent sample t-test. T is italicized. And when you do yours, is the test that you got is an independent sample t-test or is it a dependent sample t-test? Visual analysis of the histogram indicated normality distribution kind of, and the results of the KS test were neither statistically significant in this because they were 0.5 for this one and 0.5. So remember, it needed to be greater than, so they weren't statistically significant. Less than 0.05 is when they would be statistically significant. So that means they do satisfy the normality condition. Note that the P for KS test is the lower bound of the true significance. What does that mean? Let me go back and show you that this is P is the lower bound of the true significance. So these are the two things, and this is the correction that they have done. You need not know what type of corrections it is or what it includes, but this is the way APA reports this data. Note that P was the lower bound and Lilliefors significance correction was used. The results of the Levene's test indicated homogeneity of variances. This should have been of homogeneity of variances F 1, 22. Where does that come from? This is 1, 22. Degrees of freedom equals to 0.78. So I'm going to make sure you all understand this part. When reporting data for APA, you use 2 decimal points. Okay, so the degrees of freedom, and then you have to put a 0 and the decimal point, and then 2 digits after the decimal point. So if you look at the table, and this is the statistics here. If the third digit is a 5 or more than a 5, you round it off. But if it is a less than a 5, you just report the first 2 digits. So if we look back at the KS test, this is the statistics, and you look at the third digit here. The third digit is 1. So we do not round it off. We just report 0.12. That is what we reported here. And then for the second one also, the 1 is not significant, so we report 0.19. I think I skipped So this is the picture group, and then P, when you report the P is italicized, equal to, there is no zero, you put a decimal point, and then you put your P value, that is the 3 digits after the decimal point. Okay, so P is 0.022 and this is 0.20, sorry, 0.20, 0.200. And in this case, I have 2 degrees of freedom. Look at this, F is italicized, D is italicized, and then I have point, and then I put my, I assume independence because there was no evidence that one participant's score affected another participant's score during data collection. Okay, so this is how it, so once again, this is the script. Now we are actually going to look at what are the values and where do they come from. So to do that, we are going to compare the means of the independent sample t-test. So let me go back to my data. I do analyze, compare means, and I have an independent sample t-test. So I'm going to click on it. So I will put my anxiety scores as my test variable because that is the one I'm testing. I'm going to put my group as grouping. I'm going to define group 1 is 0, group 2 is 1, continue. I want to make sure that this is 95% confidence interval, and then I am going to run my statistics. So here is my statistics that I have got about the anxiety scores. I have put, so the group statistics is picture was, number was 12, real spider was 12. This was the mean for the picture, the group, that's all, the standard deviation, the standard error of mean. Remember how we how we change it to saying M, SD, and SEM. So this is what is given, and this is the independent sample t-test. So look at it. If you can see, I do not have horizontal lines. I only have the horizontal lines in the heading of it. Once again, APA formatting of the tables is very important. If you are doing a quantitative analysis, you have to remember that you have to format the APA tables. The APA tables that you will get from the output run by me from the test would not be in APA. So you have to format them. So here is all my significance given. If you would see that F is 0.782 here. And then where is the P? So I go look at the significance level, and this is my P, that is 0.107. So is it, our criteria that was set was P has to be less than 0.05, but it was not met. So that means we say we fail to reject the null based on this information. Significance is greater, so that means so now the question, or what is this paragraph telling you about, is you actually see is the 2 lines, right? One is equal variance is assumed and equal variance is not assumed. Right now when I was talking, I was looking at this line. The reason that I was looking at this row and I was using statistics from here is because I had assumed homogeneity of scores above. So if you look at table above, I had said that this is satisfied. So I am saying that equal variances are satisfied, and hence I am looking at this point, this row, and using these values. If I was equal variances are not assumed, I would look at these. Now, if you look, you'll see that obviously these are like nearly the same, but in some cases they turn out to be very different. But in this case, they are nearly the same, and we are rejecting the null. So another one to do or think about is, or reporting statistics that is needed, is called the effect size. What is effect size? Effect size is basically telling you that what we have observed or what statistical result we have got is because is not because of chance, that there is something into it. So it is not because of chance. And so any value of Cohen's d of 0.6, like 0.5 or 0.6 and above, is significant. So how do we do this? We actually have to go back to our groups and put the mean 1 and put the mean 2. Let me go. I'm going to click on this. And so I have given you the website for this, so you do not have to worry about doing the calculations. Where do I get these scores? Here is your picture, the group statistics. So anxiety, real spider mean 47 and this is 40. So I'm going to put, it doesn't matter which one you put first, but because my experimental group is the 40, is the real spider, I'm putting that one. Then I have 11.029. It is important that you do not mismatch the standard deviation. So the standard deviation of second group, like the real spider group 1, goes here, and standard deviation of group 2, which is 9.293. And then I press compute. And when I press compute, it gives me the Cohen's d. Once again, I take 2 decimal points, but because the third one is more than a 5, it is a 6. I will say it is 0.69. I'm rounding it off. And then if R is 0.32, but this one is less than a 5, so I just report 0.32. So here I come back to this. And so 0.69 and R indicate large Cohen's d. So that basically is good for us, saying that it is not due to chance. Like this is what the results should be. They indicate medium to large effects. So how do you report? This is what is the most important part is. So this is your script for reporting. On average, participants experience greater anxiety to real spiders because M is equals to 47.00. Look here, M is italicized and I have 2 decimal digits. I have 2 digits after my decimal point. Standard deviation is italicized, 11.02. Then the picture of the spider. So when we did the group statistics, we see that the mean of the real spider, of participants seeing the real spider, was more than seeing the picture of the spider. However, this 7-point difference, that means 47 minus 47 point difference, mean difference, was not statistically significant. So when we go back and look, how did we get T? Is for the t-test, 22 from degrees of freedom equals to negative 1.68. So how are we getting negative 1.68? This is the t-test value, negative 1.68. You can report the F value. You can say F parentheses 22 and this value also. We are reporting the t-test value. And comma, P is italicized, equals to 0.107. Comma, D is your Cohen's d, equals to 0.69. 2 digits, 0 before that. P is the only one that does not have a 0 or a digit before the decimal point. 95 confidence intervals. And now you look at these two values. For good reporting, researchers also do the 95% confidence interval, and we have talked about this in your intro to research class and previously, that means that if I keep taking samples out of the big population and I plot them, like I keep taking the samples and I plot their means, so they will fall under the 95% accuracy. So how do we find out that one? Let's go over there. So I go back to my data. This is my data. I click on analyze. Let me make sure. Click on graphs, and then I click on legacy dialogues, and what I want is the error bars. So I click the error bars, and I can just do whether I want simple or but I want simple here, and I want summary for groups of cases. So I do that. I have 95% for my variable category access. I put those in and I press OK, and I get my error graphs. And this is also what gives me my lower bound and my upper bound. Lower bound and my upper bound. And so if you look at it, I actually have the lower bound and upper bound right over here also from that. So this is just to show you negative. And I remember I'm looking at the first line over here. The lower bound, 2 decimal points. Upper bound, 2 decimal points. Negative 15.63 and 1.63. That is what I report here. So I showed you the error graphs for you to see the difference. But it is completely not necessary because you have the information from here too. So this is how we do that. I have used different data about, like this one is about the picture of the spider and the real spider. And then there are other research studies that you're going to see in the Mann-Whitney test and in the dependent. These are from the book that is the Andy Field statistics book. There are other that have taken from other research books for you guys to understand the statistics better. I am happy to clarify anything. I am happy to answer your questions. I am going to give you a summary once again. This is an independent sample t-test because there are 2 independent samples. We have 4 assumptions. The normality, to look at whether the dependent variable is an interval, to look the independence of the scores, and the homogeneity of variances. So in this case, we did satisfy it. We have 3 ways to look at normality: the histogram to see whether it is n is greater than 30, and the KS test. And then for homogeneity, we have the Levene's test. We satisfied the assumption, and so we did an independent sample t-test to find out the means of it. But if the assumptions are not satisfied, we do a Mann-Whitney test, which is the second part of this week, which is already on your D2L. If you have any questions, please don't hesitate to ask. Your script for assumption is over here. And then the script for reporting the test is, this is your script for reporting the test. You report the numbers, you have your Cohen's d. This is a link that you can use directly. You do not have to try to calculate it using a calculator or anything. If you have any questions, please do not hesitate to ask, and best of luck for this week.